The topic is correlation outliers. So let's read the definition. Correlation describes linear association between two quantitative variables. Correlation is sensitive to outliers. A single outlier or outlying value can make a small correlation large or make a large one small. An outlier, by definition, is a point that does not fit the overall pattern seen in the scatter plot. So first, let's just talk about what we mean with an outlier. For example, let's call this A, B, scatter plot C, scatter plot D. Right? If you look at the scatter plot A, is this point, is the point A an outlier? If you want to know what you do, you look at the, see, you read the definition, you look at the overall pattern. See, the overall pattern goes that way. So this is an outlier. Right? What about the point B for scatter plot B? Is it an outlier? This is not an outlier because look, if you do the overall pattern, if you just draw that line, so B lies on the the point P fits the pattern. So no, not an outlier. Now what about the point C? Same thing. Here's the pattern, not an outlier. What about D? It is an outlier. Why? Because look at the pattern. So it is an outlier. So at least we know what an outlier means now. Now let's do the next example. A study of traffic delays in 68 US cities found the following relationship between the total delays in total hours and mean highway speed. And the question is, and here's the scatter plot, the question is it appropriate to summarize the strength of association with the correlation? So first, the first thing we need to check is number one. Is the correlation always describe a linear association and between two quantitative variables? First of all, we have two quantitative variables. Speed, we have the unit, so it's quantitative. Delays, we have the unit, which is hours, so it's quantitative. We don't have a problem. However, it doesn't look like, it looks more, see, if you look at it, it looks more curved. Even if you want to try, you could try to fit a line. But even in that case, we have a lot of outliers, which means, remember, let's read it right here. Number 2 says correlation is sensitive to outliers. A single outlying value can make small correlation large or make a large one small. But we have a lot of outliers. There's one, here's another one here, here's another one there. So the answer will be no. It will be, first of all, you can say we have presence of a lot of outliers. And even the main cluster, which is that one, even the main cluster is not linear enough. But the presence of outlier is enough to say that we can't use a correlation. The correlation would not summarize the strength of the association. And that's it for this example.